this lesson, we're going to learn how to do unit conversions through a method called dimensional analysis. The first step is to look at equalities. Equalities are units that relate one measurement to another. You do not need to memorize these for this course. You just need to be able to use them. So these will be in your notes or given to you. So notice how they relate one measurement to another. For example, there's 1,000 millimeters in 1 meter. Or for mass, there's 1,000 milligrams in 1 gram. So these are all measurements that we can relate one unit to another. In a problem, you'll be asked to convert one unit to another. For example, in this problem, we're asked to convert 2.5 months to minutes. This is about how long your summer break is. So we're going to figure out how many minutes you spend in summer break. So we have to convert months to minutes. The first step is to develop a flow chart. So we're going to devise a plan to go from months to minutes. There's more than one way to do this, but we want to try to choose the one that's the most direct. So if we start with months, what would be a smaller unit of time to get us to minutes? Well, we could go to days, and then from days, what's a smaller unit that we can start working our way towards minutes? We could do hours, and of course then we can go directly from hours to minutes. So this is a flow chart or a plan of how we can go from one unit to another. The next step is to carry out the flow chart using the dimensional analysis method. So this method is one that's used in physics, and it's used by chemists everywhere. So we're going to be learning this method. We'll also use it a little bit later on in the year. For dimensional analysis, what you should do first is to write down the number that you are given with its unit. We are given 2.5 months. So we're going to write down 2.5 months as our number to start with. The next thing you're going to do is write down a fraction bar for however many steps you have. I like to look at the flow chart to tell me how many steps this is going to take. I have 1, 2, 3 arrows, so I know that this is going to take me 3 steps. So I'm going to go ahead and write out 3 fraction bars with a multiplication sign because I'm going to develop 3 steps to go from months to minutes. In a fraction, if I want something to cancel out that's in the numerator, I'm going to put the exact same unit in the denominator. The reason I'm doing this is because I do not want to end up with months as my final answer. I want months to cancel out so I can go to days. So I'm going to put days in the numerator because that's the next step in my flow chart. But my flow chart says that's not where I want to end up. I want to go to hours. So I need days to cancel out. I'll get days to cancel out by writing it in the denominator of the next fraction bar. And of course the flow chart says to go to hours next, so I'll write that in the numerator. I don't want to end in hours though, I want to end up in minutes. So I'm going to get hours to cancel out, and we're using this diagonal pattern of the numerator canceling with the denominator. And the last unit in my flowchart is minutes. So I have set up my units to cancel out. The next step is to plug in my equalities. So the first equality that I'm going to fill in is how many days are in a month. That's about 30 days in 1 month. Next, how many hours are in a day? It's 24 hours in 1 day. Notice how I'm writing the number next to the unit that it belongs to. I didn't say there were 24 days in 1 hour. That would be wrong. I'm writing the 24 next to the hours because that's how many hours are in 1 day. And the next equality, there are 60 minutes in 1 hour. So the next thing we have to figure out is this multiplication or is this division? We are going to say that this is multiplication because, I don't want that. The reason this is multiplication is that all of these numbers are in the numerator. If it would help you to put this first number over 1, you can do that, but you don't really have to acknowledge that it's over 1. You can just understand. If it's in the numerator, it's essentially over 1. So in your calculator, we're going to type out 2.5 times 30 times 24 times 60 to get the final answer. And it's going to be a large number. I got this number. And we're going to put the final unit that did not cancel out as the unit of my final answer. So this is how many minutes we spend on summer break each year. That's a lot of minutes. Let's try another problem where it's not units of time, and we're going to have to use our equalities list in our notes. This problem is asking us to go from centimeters to miles. So let's develop a flow chart of how I'm going to go from centimeters to miles. I know I'm going to have to start out with centimeters. Okay, so here's centimeters in my list. How can I get to miles? All right, I see that here is miles, and miles is related to feet. So I somehow need to get from centimeters so that I can get from feet to miles. What would be in between? Well, this is converting to inches. Why don't I go from centimeters to inches, then to feet, and then to miles? So that will be my flow chart. Centimeters to inches to feet to miles. There is more than one way to do this, but this is just one way that we can do it using the equalities that we have. So the first thing you want to do is to write down the number that you are given with its unit. The number I was asked to start with was 498,000 centimeters. Then you can count the number of steps that it's going to take to get there. 1, 2, 3 steps. So I'm going to write out 3 multiplication signs in a fraction bar. 1, 2, 3. Now we're going to follow that diagonal pattern where the numerator cancels with the denominator as I work my way down the flow chart. So I need centimeters, my first unit, to cancel out. So I have centimeters in the numerator, I'll put it in the denominator to cancel out. The flow chart says I need to go to inches next, so I'll put that in the numerator. But I also don't want to stop at inches, so I need to get that to cancel out as I work my way down the flow chart. And I'm going to end up with going to feet next. And of course I don't want to stop at feet, so I need to get feet to cancel out. And I'm going to go to miles next. So notice this diagonal pattern that I've developed here. Centimeters will cancel with centimeters, inches will cancel with inches, and feet will cancel with feet. If you don't see this diagonal pattern of units form when you set up your problem, you know that you've done something wrong. So let's go ahead now and plug in our equalities. How many centimeters are related to how many inches? Well, we got to go to our notes. It says there are 2.54 centimeters in 1 inch. Notice how the 2.54 is written next to the centimeters. Here, the 2.54 needs to be written next to the centimeters as well. And the 1 needs to be written next to inches. So I'm going to write 1 next to inches. It cannot be reversed. There are not 2.54 inches in 1 centimeter. It must be written exactly as the equality lists. Let's look at the relationship between inches and feet. Notice how it has the 12 written next to the inches here. So I must write 12 next to inches here, and the 1 next to the feet. Do not try to memorize if these should go in the numerator or denominator. It only depends on where your units are. So fill out all of your units first, then look at your equalities list. The final one, relating feet to miles, says there's 5,280 feet in 1 mile. So I need to write the 5,280 next to the feet and the 1 next to the miles. To solve this problem, this is going to be division. So as I work the problem out, in my calculator, I'm going to say that the first number, it will be divided by all of these other numbers. Remember, in the denominator, it is division. So in my calculator, I would type out the following. The first number I was given divided by this number in the denominator, divided by the next number in the denominator, 12, divided by the next number in the denominator, 5,280. So this will give us our final answer. So go ahead and plug that in your calculator as I am. Hit all of your division symbols right in a row. You do not need to press the equal sign in between. So I got that the answer was 3.09 if you round to 2 decimal places. And my final unit is miles because that was the only unit that didn't get canceled out. So this is my final answer. So if I were to tell a friend, after school I ran 498,000 centimeters, I was really telling them that I ran about a 5K, 3.09 miles. Let's look at one more example. This one's a little bit shorter. It asks us to convert 7,800 grams to kilograms. So we need to develop a flow chart getting us from grams to kilograms. As you look in your flow chart, notice that grams can be directly related to kilograms. This is a really short one-step problem. It's going to be so short that it will seem kind of difficult just because it's so brief. We're going to start by writing down the number we were given, and if you count the number of arrows in our flow chart, it says it's just one step, so I'm going to write out 1 fraction bar. If you ever write out too many fraction bars, you can just erase the extra ones, or if you didn't write out enough, you can always add some. So we need to get grams to cancel out, and we need to convert to kilograms. Notice our equality says that there are 1,000 grams in 1 kilogram, so I'm going to have to write the 1,000 next to the grams. So here's the 1,000 next to the grams, and now I'll write the 1 next to the kilograms. So this will be division by 1,000. So in your calculator, type the first number divided by 1,000, and you get 7.8 kilograms. Notice how all the units canceled except for the one unit that I wanted to convert my answer to, kilograms. So circle that as your final answer, and that is how you do unit